All right. So we are recording. All right, well, thank you everybody for joining me in this what is it, March 2022 edition of Houston Job Users Group, and I'll be presenting a 10,000-foot overview of Kafka, kind of not just the Kafka APIs, but the entire sort of ecosystem that all the different components that are typically seen are available to use in a Kafka environment. So I recently passed the Confluent Certified Developer for Apache Kafka test. I studied for quite a while, in fact, and I really wanted to share the love. Basically, there's a lot to it, and I thought I'll at least give everybody a high-level overview of what's all involved, basically. So I guess a little bit about me. For those of you who don't know me, my name is Jim Bethencourt. I have about, I guess, 18 years or so of software development experience. I lead the Houston Job Users Group. All of the upcoming meetings are posted there. www.hjug.org. It'll redirect you to Eventbrite. Improving is a great company to work for. I'm the happiest I've been in a really, really long time. If you want to connect with me, I'm on LinkedIn, LinkedIn/Jim Bethencourt. Twitter is Twitter/Jim Bethencourt, and GitHub is GitHub/Jim Bethencourt. So again, feel free to reach out to me, connect. Happy to get to know you. What else? What's in my tongue? Anyway, so I want to also mention to you about improving the virtual talks. We have virtual events every Wednesday and Friday at lunchtime. They're usually 30 minutes to an hour, and a lot of great talks. I recently helped to produce one about content writing. A content writer, she coaches folks who want to write blog posts, and she helps monitor social media. She shared a lot of her experience, and all these are posted on YouTube at YouTube/user/improving enterprises videos. So there, if you want to check that out, please feel free. And then also, thank you to our sponsors. Improving is providing the streaming hosting for this, and improving.com is the website. Again, it's a great place to work for. We're hiring. I'm actually currently ramping up for a new project. So if you want to, you can reach out to me again over LinkedIn and let me know, or you can email me jim.bethencourt@improving.com. And let me know that you're interested, and I'd be more than happy to pass along your resume to the recruiters. And also another thing, that's right, Improving is a Confluent partner, and I was able to leverage the partnership assets with training, and also we have a lot of great learning resources through Udemy. And I was able to use Stefan Merrick's courses to study for the Kafka certification exam. Also, sponsor AgileLearner.com. Venkat Subramaniam has raffled off he's offered a one-year subscription to a lucky member for this meeting. And then also, so it's a one-year subscription to his website, AgileLearner.com. A lot of great resources there, a lot of great recorded classes. HelloTomorrow.com. They have offered a one-year sonograph license. It's a great tool, helps to identify dependency cycles. And then JetBrains.com. They're raffling off a one-year IntelliJ Ultimate license. That's quite nice productivity IDE. I love it. I use it every chance I get. Structure101.com. They've offered a one-year Structure 101 IDE plugin license. It's also identified dependency cycles, and again, also quite a nice tool. And webucator.com, they're offering a voucher for one online self-paced course. And then you can also win any one of these that you're interested in on this Google form right here. I've also pasted the QR code right here. If you want to snap it real quick with your phone, specify what you're interested in, and Dan will go ahead and take care of that tonight. And he's really great about it. And for all those who all of those of you who are watching from YouTube, sadly, this won't be available after tonight. So sorry. Now, one thing that all of you can win is $100 free of promo usage from Confluent Cloud. So you get some I think some budget initially, but this will give you an additional $100 free. You can snap that QR code. But also, you don't have to use Confluent Cloud to practice Kafka. All of the tutorials that they have come with really great Docker Compose files that are easy to use with Docker Desktop. So don't feel compelled to use Confluent Cloud. Confluent does a great job with their tutorials on developer.confluent.io. And to make it easy for you, so you don't have to spend any money. You do want to have a powerful enough laptop or desktop that with at least 16 gigabytes of RAM, though, because it spins up quite a number of Docker containers. So if you want to run all of them, as well as your IDE and anything else that you might run in the background, you want to make sure you have enough information, enough memory. And also, quick note: this promo code needs to be activated before December 31st, 2024. So plenty of time. And it will be valid. It'll be available for consumption for 90 days, starting on the date of activation. And it'll be automatically applied to any usage charges incurred after activation. And unused promo value on the expiration date will be forfeited. So if you receive an invalid promo code error when trying to activate a code, this means that all promo codes have already been claimed. And also thank you to Dave Klein, who has provided me with some great slide assets. This is one of them, and some others that you'll see towards the end of this presentation. So I guess first question you're probably already asking yourself is, why Kafka? Why is it not showing up? Come on. There we go. Why Kafka? So Kafka is, I'll give you a little bit of the background about the history of Kafka. It was created at LinkedIn in 2008, and it was open source in 2011. And it was created to ingest and process all of LinkedIn's data in real time, because before then it was run in batch, and so basically be getting posts that were maybe a day old. They all ran through Hadoop, and they're processed in batch, if I remember correctly. And also, what Kafka really did is it also allowed other systems at LinkedIn to tap into all of the LinkedIn data. So the data wasn't siloed. So if you're wondering how LinkedIn can take and say, hey, we think you might know this person, or we think you might be interested in this person, following this person, or we think you might be interested in this group, or this hashtag. That's Kafka is kind of help what makes that possible. The code creators left LinkedIn in 2014 to start Confluent. The three code creators, and others quickly joined them. And then the Kafka Streams library was added in 2016 in version 0.10.0. And then another piece called KSQL was added, I want to say 2019. It's pretty neat, and I'll discuss that a little bit later. All right, so common Kafka use cases. Course messaging. It can replace JMS or RabbitMQ or some of the others that are out there. RabbitMQ can certainly beat Kafka in terms of latency, but not latency plus throughput. Kafka can, again, RabbitMQ, if you need ultra low latency, definitely take a look at RabbitMQ. But if you need fairly low latency plus large batching, bulk operations, take a look at Kafka. It can also be used for monitoring reporting. So if you want to have, if you want to be updated with the status of your application, you can use it for that. Event processing and querying. This is huge, especially with Kafka Streams. So you can take and as events are generated, you can analyze them. You can analyze the data as it's happening. So you don't have to wait and process things in batch. So you can know now rather than having to wait again for a batch job. And again, also querying. It's easy to actually query the events using Kafka Streams or with KSQL. Stream ETL. Get a water drink water real quick. So streaming ETL or extract, transform, and load operations, you can do what's effectively streaming ETL. So instead of having to capture everything in a single batch and again process it daily, you can do an ETL, perform ETL operations as they go, as the data comes in. I was working on an insurance healthcare app, and we used Kafka for exactly this, and it can handle quite a lot. So we were spinning up to 6,000 pods in a test, and the Kafka cluster was able to handle all of it. It was quite impressive. Also for customer engagement. So if you want to take and track what your users are clicking on your website, or what they're searching and what they're clicking on, you can make recommendations to them as to what products they might be interested in, what links they might be interested in. You can also do A/B testing. A few other things skipping my mind right now, but there's other things you can do around that as well. Also, predictive and real-time analytics. One really neat use case that that's been mentioned is you can use Kafka with MQTT sort of IoT devices, and they talk about for these ore haulers, these huge ones that you have to climb a ladder up to get into. They'll attach put these sensors on the wheels that each cost $10,000, and so they can get a good idea of when a wheel is about to go out, and so they can take and bring in that truck and put it into maintenance mode, do preventive maintenance on it instead of having that truck die in the field, basically. And then I'd hate to see how big the tow truck is for one of those. So they can basically see and identify when a truck is about to have issues. So what next? So why choose Kafka? It is scalable. You can have up to 200,000 partitions in a single cluster right now, but it can go into the millions. I'll talk about that later. Pretty soon here with the next major release of Kafka that's coming out. It's also the messages that are generated are durable. So what does that mean? That means that they have stickiness. They'll stick around. So with messaging systems like JMS and some others, when you put a message in the system, when somebody reads it, it's taken out. It's gone. Nobody else can look at it, which makes things kind of tricky. It kind of limits what you can do or who can use that message. So with Kafka, you can take and the message is written, and then it stays written and it doesn't disappear. And so you can use that message for any number of use cases you can think of. So whenever you have different parties that are interested in it, they can all read that same topic, that same message. Again, it's also reliable because there are multiple. It has a replication built in, and so if one broker goes down, then you have other replicas of the same partition with the same data on it. It's also real-time capable. So the producers, when the producers write to the broker, then it doesn't actually get written to disk right away. It stays in the page cache, and then the consumers can pick it up right away. So it's incredibly fast. And then also you can monitor how close to real time it is based on something called a lag. And also it's a very high throughput. So again, you can have quite a large number of consumers and producers all writing to the same topic at the same time. It's also interoperable across languages. So let's see, let me jump to there real quick. So programming language support, you have commercially supported, you have Java, C++, Go, .NET, Python, and Scala. there's a Java library, and you have pretty much all the others are based off of the C++ library. I think that's Go, .NET, and Python are at least. Scala, I'm not sure if it's based off the Java library or the C++ library called librd Kafka. But one thing to be aware of is that the Java hashing algorithm for when it creates a key is different from the librd hashing algorithm. So you can set that hashing algorithm, but you want to make sure that if you do commingle languages, that you make sure that you use that you set that hashing function correctly. And also, there are quite a number of community supported libraries that are all primarily built again off of the same librd Kafka library. And then so the different parts of the Kafka ecosystem. So this is primarily what I'll go over tonight. It's not going to be too code heavy. I don't have any live examples. Nothing dangerous basically. But I will show you a little bit of code though, so you can get a better idea of what code would look like. So you have the Kafka Producer, Broker, and Consumer. So I'll go into each of these a little bit more, and then Zookeeper, which will actually go away soon. Kafka Connect allows you to quickly and easily talk to outside systems. We also have the Confluent Schema Registry, which allows for graceful evolution of your data types. You have the Confluent REST proxy, which allows for access to your Kafka topics through REST APIs. You have Kafka Mirror Maker, which, as you can probably guess, allows for replication across multiple Kafka clusters. You have Kafka Streams, which allows for in-flight processing of data, and the KSQL, which sits on top of Kafka Streams, and allows for a SQL-like representation of the sorry, you can use SQL to write Kafka applications, basically. Put it that way. So, all right. So also there's Java library and framework support. So for all of you who are Java developers out there, just like me, there is Spring framework support. It also supports Micronaut and Quarkus via SmallRye. I've used Spring primarily, but I've seen some examples again with Micronaut and Quarkus. There are also independent Java libraries that are not bound to a framework. Vertex has a Kafka client, and then there's also one called Greyhound from Wix. It's on all of these are on GitHub. And then ZIO Kafka, I'm not familiar with it. I haven't used it. I came across Rhapsody and also Wizard Kafka. So if you're a Wizard fan, you can certainly check that out. And then for those of you who are Akka fans, Alpaca is available for you. So there are also, again, in this big world of software development, you have alternatives. So for the message brokers, you can certainly use JMS or RabbitMQ. There are also streaming platform alternatives. And I want to say there are Kafka Connect integrations for at least Storm and Samza. I haven't used any of these myself, though there's been a lot of a bit of benchmark smackdown basically between Apache Pulsar and Apache Kafka. So it's quite interesting. Basically, who can do what better and faster and scale and be multi-tenant natively and things like that. It's almost kind of funny in a way, but they all serve similar use cases, and it certainly is your choice. And also Apache Bookkeeper will help serve the commit logs. Keep it if you don't want to use Kafka, but you still want a commit log mechanism. And so before I move on, are there any questions? Because I'm about to start kind of diving deep into the different components of Kafka. Anybody have any questions? Okay, all right. thanks. I'll move right along then. Okay, so the first piece I'd like to talk about is the Kafka Producer. So the producer writes messages or events to a topic. You can think of a topic like a database table, basically, because you have a data type. If you use JPA or Hibernate, you have a data type, and each instance can be persisted to a topic. It can be written to a topic, and as well, just like with the JPA or Hibernate, any producer can write to any topic, just like any data access object or DIO can write to any database table. So messages contain a value and a timestamp. They have to contain at least those. The value is what you put in, and then the timestamp is added for you by Kafka, by the Kafka producer, whenever the message is written. And then messages can optionally contain a key and a header. Now, if you use just the Kafka producer and consumer paradigm, you don't need to supply a key. However, if you use Kafka streams, you must supply a key. I'll talk about that a little bit later. And when I talk about Kafka streams, and then optionally, you can add a header to a message. It's not required at all, but it can provide information. So especially if the data in the message has to be encrypted, but you still need to have some kind of metadata about the message. And also, again, a key can be any object. It doesn't have to be any kind of a Java primitive strictly, but typically I've seen that is the case, but it does not have to be. And then messages are, again, as I mentioned earlier, immutable, and they are durable. So messages can't be changed once they are written to a topic. And they're also durable, meaning that they will stay on that topic for as long as it is configured, meaning that anybody can come along and read it, at least who has access to that particular topic. The messages are also deleted typically after 7 days by default. However, this is configurable, and so if you want to have it stored for only 5 seconds, 5 minutes, or 5 months, or 5 years, those are all valid options. And also, interestingly, one of the fairly new features of Kafka is to be able to have tiered storage. So if you want to have all of the most recent messages hot, and then you can in sort of your hot or your premium sort of storage, and then older messages can get moved to cool automatically, and then eventually archived if you really want to keep messages that long or move them to archived. But again, that can get kind of tricky if you start archiving data in like serious archive storage. Then a special kind of topic called a compressed topic keeps messages forever, mostly, but not but only the message with the last message with that particular key. So if you want to have a compressed topic, you need to have a key with your messages. And so say if you have a message with a specific key that's written to that compressed topic, then whenever another message with that same key is written, then the prior message will be deleted, typically within 24 hours. But it is configurable as to when that compression takes place. But again, typically it's roughly every 24 hours. That what's called a segment is generated, or a new segment is created. So any questions about Kafka producers? Okay, again, so producers write the messages to a topic through an API or through the REST API. And then you have a sample Kafka producer code. So this was from I can't remember where it's from. I think some sample code from the Kafka tutorials. So from developer.confluent.io. So here you have the Kafka producers. Let me see if I can do the laser pointer. So you got the Kafka producer application. It's loading the properties here, and so you're passing them in all via command line. And then you are you're getting that output topic name, and then you are creating the producer here with the properties. And then you're actually taking and creating the producer application that will actually perform the product that actually do the writing. I think that's that's actually this right here. And then the producer application is what's going to call produce basically. You have you're reading a file, as you can see here, and you are taking and capturing the metadata, such as the count of collecting the lines, and then you are that's right, yes. So you're streaming the lines that you want to produce, and then what's captured, what's returned from the stream, is the metadata. So what you're finding, what you're capturing here is the information of, has this been written yet or not, basically. So it doesn't return the actual data that you wrote, only the metadata that's returned from the broker. And then so once you so now what you're doing, you are taking and printing the metadata that you've brought in, and then in these messages that you are taking and sending, it is taking and evaluating the messages, and then producing them it's creating a producer record and then sending that record. Any questions?
So I do have a question about consumers, but maybe it's too early. How would a consumer know what data to consume when the data persists for a long time?
Yeah. So I will talk about that. Let me make sure I mention capture your question. So how does a consumer know what data to consume? Correct? All right, that's a good question. Thank you, Tony. Appreciate it. All right. So Kafka Brokers. So Kafka Brokers all work together in a Kafka cluster. So so these are typically virtual machines or some kind or another, or they could be a bunch of different independent Docker images, for example, if you wanted to do that. So if you wanted to spin up 3 different brokers in your local test Kafka environment, you could do that. And you have topics. All of the topics are spread across partitions on multiple brokers. So what you have say 3 partitions, and they would all be spread out across 3 different brokers. And each of these partitions is also replicated across brokers as backups. So you have a primary partition for each of these. So you have it's called a lead partition for a particular topic, and then so have a lead partition for each of the individual partitions that you created, and you have a backup partition, or typically 2. So you can have each of these partitions that are the primary partitions for are spread out across the brokers, and each of these partitions is so the scalability. This is where the scalability of Kafka comes in. So for each partition you have, that's the scalability factor you can handle. So if you wanted to have a high throughput, you could have, say, 100 partitions for your topic, and so you could have 100 consumers in a consumer group, which I'll talk about in just a minute, each reading from one of those partitions. And each of those partitions will also have 2 additional replicas as backups in case one of those brokers that the partition was running off of goes down. And so right as it is right now, a cluster can have up to 200,000 partitions, but Zookeeper will go away soon, and it can have millions without Zookeeper. So there's actually a great article called 42 Ways Zookeeper Removal Improves Apache Kafka. I'll show you here real quick. Is that right? No, you can't see that. I'm sorry. So I'll drop that in the chat real quick here. If you want to go take a look. So check that out. Yeah, you certainly can. But it will improve Kafka in many, many ways. And again, I'll go into Zookeeper in just a little bit here. But are there any questions about brokers?
I'm sorry, Jim. Could you elaborate on what a partition is?
Yeah, sure. So just like a database partition, if you're familiar with database partitions, it'll take and split out the data across different physical chunks. So if you want to have, say, A through M and L through P and Q through Z, for example, you can partition your data that way. Or you can that's by default it will be round robin, but so again your data will be split out across each of these partitions, so that way each of them only has a subset of the data. And by doing this, you can increase your scalability of your consuming applications. Does that answer your question, Craig?
Yes, it does. So
Okay.
does Kafka actually have queues as well, as it only pub sub?
You could treat it as a queue if you wanted to. It just depends on your use case, but there's no reason you couldn't treat it as a queue in your consumer. Yeah, so I'll talk about that in just a minute, actually, when we get to consumers. But thank you for the question. And again, you can, with partitions, you can, by default, it's round robin. But if you're using keys, it will it will use it will place the data in a particular partition based on the particular hash function of the key. For Java, I think it's murmur2 is what the hash algorithm is called. But you can also implement your own custom partitioner. So if you want to take and have a particular key go to a specific partition and treat that as special. So say like if you wanted to have, if you're doing a large batch ETL or a large ETL streaming job, but you need to be able to handle smaller customers as well, you can write a custom partitioner to write to say a particular partition called small jobs or something like that. If you wanted to do that, you certainly could do something like that. Either if you see that one partition is getting somewhat lopsided, you could handle that with a custom partitioner. You know, I don't know. I've only been on one engagement with Kafka so far, so I can't say how broadly it's used, but I want to say it's not used too frequently if I had to guess. All right, so you do have quite a number of broker deployment options. So Confluent is a cloud provider, cloud hosting provider, and it integrates with Azure, it integrates with AWS, it integrates with Google Cloud Platform, and it integrates with Oracle, and it can also integrate with your data center. So, or if you wanted to, you could use Kafka as a way to move data from your data center to a particular cloud. There's also Azure HD Insight. It was what we used at my prior client engagement. And so it's completely managed Azure implementation. So if you don't have access to the Azure Marketplace, it's a viable option. You do have, for pretty much all of these, except for Confluent, you would need to deploy all the Confluent source available licensed components yourself, but it's very doable. And then again, also there's Azure Event Hubs, which is another option via Azure. It's not quite as scalable though. You can only have a limited number of partitions that you can use, and you don't have the ability to use Kafka streams. But if you just need messaging, it's a great it can be a decent option. AWS MSK. I would say MSK stands for what? Managed Solutions for Kafka or something like that. You also work with Heroku. Heroku has managed service for Kafka. Then Heroku has a Kafka service available. There's one called Conductor.io, and then also Avian.io and Instacluster.com are all providers of Kafka Brokers as well. And then if you want to deploy it to Kubernetes, if you prefer to deploy it to Kubernetes cluster, you can do that as well. Confluent has a commercial offering. And then Red Hat also has one called Strimzy that is open source. So if you want to kick the tires on it. Another one is called K-Operator. So you can try that out as well. And both of those are available on GitHub. So you can check them out. Any questions about brokers? I would definitely suggest you try not to deploy it directly onto Linux yourself, at least in a cluster, because it would be pretty difficult to take and manage that yourself. You want to have some kind of an operator or a cloud offering manage it for you, because there's a lot that's going on there, and a lot of configuration that brokers need to have, basically. But if you really want to do it, I'm not stopping you. All right, so I will go ahead and move on from broker deployments unless there are any questions. Okay, so Kafka Consumer. So a consumer reads from one or more topic partitions, and a consumer can also read from any topic, as long as it has access rights to it. Kafka does have the ability to have ACLs, so if you wanted to limit the writing to or reading from a particular reading from a particular topic, you can place access control lists or ACLs on it. And also, so consumers scale by working together in what's called a consumer group. Each consumer in a group reads from one or more partitions, and consumer scalability is limited by the number of partitions, and so if consumer groups will rebalance if a consumer or broker becomes unavailable. So you can have more consumers in a consumer group than you have partitions. So, but it'll just be sitting there and doing nothing. However, if one of your consumers does go down, then the consumer that is sitting there idle can take over the job or the job of reading from that partition that the consumer that died was reading from. And then consumer groups also keep track of processed messages by using what's called an offset. So the offset is basically if you look at a series at Kafka is a series of blocks. The Kafka partition is a series of blocks. The offset is what has been read so far in that chain of blocks. And so each consumer group can be at a different offset and can read from it doesn't have to read only from the most recent one. So also one option, Tony, does the consumer know what data to consume? To your question, so it will the offset is captured. So and so there's a special topic called consumer group offset, and it will keep track of how far the consumer group has gotten in that particular partition for that particular consumer or consumer group. So it does indeed know what data to consume. And if you're interested in all of the data, you can specify offset equals earliest, and you can read all the way back from the very beginning of the earliest message in that available in that Kafka topic, or if you want to if you only want to receive the latest, you can specify latest as your offset whenever your consumer starts up, or you can do some stuff where you can specify what offset you want to start reading from as well, but you don't usually see that happen. So are there any questions so far about Kafka consumers?
So you mentioned event handling.
Yes.
So a consumer would be like a listener for an event.
Yeah, exactly. That's right. Thank you, Mark. So whenever a new message gets put onto the topic, then the consumer group will listen and will grab that message or that event from the topic, and can then process it and kick off a new chain of events. And again, in the last client that I was deployed to, we would have a message that was written to a topic. Then you'd have a consumer that would listen to it, and then would then take and create multiple new messages or events from that, and would take and would be written to other topics. But also, again, if you wanted to take and use that and again in the event for the IoT event listeners, you could use it for that as well. So it's, again, that's also very much an event-driven mechanism. So you could display data to a dashboard or kick off whatever kind of application you wanted to have run, for example. So here's some sample consumer code. So again, this is a sample consumer application. Again, it's reading the properties. It's loading the properties here, and then getting the where that's from, where the properties location is the properties file is located, passed in as an argument, and you're getting the property file path to read from, or to write from rather, and then consumer apps props. This is your Kafka consumer application, and then you have a records handler that's going to handle the applications that we're going to call to process it, and then the consumer application that will actually take and consume that will actually do whatever it is that we want it to do. And the shutdown hook here, we can call a shutdown hook gracefully. I left it out for this example just to squeeze it all in the same slide. And then you can actually run the app consumer app, run the consumer application by calling run consume, and then again you're passing in the application properties. And then here we're calling this method right here, the run consume method, and then we're subscribing to the particular topic that we're interested in that was put into the consumer properties file. And then so we're sitting here in a loop basically. So while keep consuming is true, while we have data, then we're taking and creating, we're getting a new consumer record by calling consumer.poll, and we want one message, and then we're taking creating that message, and then we're processing it with the records handler. And then once there are no more there's nothing else to consume, we can close the application, and then it's done. Are there any questions around this Kafka consumer code? Okay, all right. So to test the Kafka Producer and Consumer, there are a couple different tools available. So there's mock producer, mock consumer. I didn't use this. However, we did use the test containers, Kafka container quite heavily. And so one other handy tool to use along with it is called awaitility to assert asynchronously. So what you want to do is you spin up your test container, and then you load all your data, and it'll run in the Kafka application, and then you can use awaitility to perform your asserts every, say, 10 seconds or 1 second or however long you want to for the next minute, 5 minutes. And it's quite handy, but it's also very powerful, and it'll allow for you to take in and do end-to-end or integration testing fairly easily. So it'll spin up the broker for you and take care of that. And you can actually write to an actual topic. Anybody else have any experience writing using Kafka testing tools that they'd like to share? No? Okay, all right. So next I'll mention Apache Zookeeper. Its primary job is as a cluster manager, but also performs what's called controller election. So there's one particular broker that is called the controller. And so Zookeeper picks that controller. The controller will take and help manage partitions. And then also manages cluster membership. So if a broker dies, it will notify the other brokers, and then they will all take and reshuffle partitions and partition data and make sure the data is adequately replicated. And they'll also perform a security ACL management, access control list management. So if you want to have partitions that are protected, again, from peering eyes, you can make sure that only specific users have access to that particular topic. The big drawback is that it's a scalability and performance bottleneck. Again, I mentioned there's about a limit of about 200,000 partitions that a cluster can currently handle. Again, because they all have to communicate, all the brokers have to talk with Zookeeper. However, this will go away soon because of KIP 500, which removes Zookeeper. Is quite a long process, but it's they're getting very, very close. With the newest versions of Kafka, you can actually configure the brokers to not use Zookeeper if you want to give that a shot, kick the tires on it. So if you want to try it out, you can go ahead and do that. The shutdown and startup times are significantly improved as well. So it'll be helpful both for deployment and for testing. So I'm sorry. Were there any questions about Zookeeper? Okay, cool. So Confluent Schema Registry. So fact of the matter is that data types will change and they will grow. So I don't know too many that don't really, especially for long-lived applications. So Confluent Schema Registry was created to address this situation, because just like you add or remove add columns to a database or remove columns from a database, the Schema Registry allows the same thing to happen for Kafka data types. So it also allows for backward compatibility, forward compatibility, and full compatibility. So backward compatibility is the default. And so you're probably wondering, well, what does that mean? So backward compatibility means that that data that was from the previous version of data can be read by the current version by the current version of a consumer, for example. So if you have producers out there that haven't been upgraded yet, but you've upgraded your consumers, then you can continue to have both versions of the producers, the old and the new, in production. With forward compatibility, you can consumers can read future groups, future data, future versions of data types. We'll also continue to read from the current data type. This is particularly helpful if you want to upgrade the producers before you upgrade the consumers, which to me in a way would seem more natural, but again, the folks who designed it probably had a good reason to have backwards compatibility as the default. And so for both of these, you can specify default values for forward compatibility. You add defaults. You add default data values for your data types that are added. For backward compatibility, you remove default data types. I remembered that for the exam when I took the Kafka Developer Cert by remembering the acronym FAD, forward add defaults. So that was something that I really struggled with, in fact, as to how to keep it straight. So I said to myself, okay, FAD, forward add defaults. That's what worked. And then for backward compatibility, you can remove defaults. And if you want to use full compatibility, so if you want to be able to upgrade both either producers or consumers, which is in a way the easiest to manage, always remember that you want to either add or remove defaults. You both want to add and remove only defaults, basically. You never want to remove a data type that is not a default value, that is not a defaulted type. And then incompatible changes will trigger errors, so you'll know very quickly. It will so you won't make any grave mistakes, basically, that will take and corrupt your data, at least not based on data types. Then also one other handy thing is that the Confluent Schema Registry caches schemas to reduce message size. So if you have a large data type, it's sent with every single message by default if you're not using Confluent Schema Registry. So the Confluent Schema Registry will reduce the message size, and it also supports multiple data formats. So data is not written to Kafka natively by you can't just write a particular any old object type. So Jared, you asked by default, you mean fields with default values? Yes. So like a number default to 0. Yes, exactly. Yeah. So you want to you actually need to specify in the schema what the default value is, and then you can either add or remove or both. So if anything downstream needs to use that, needs to have a placeholder value, it will be able to use that value. So again, Confluent Schema Registry supports multiple data formats. You can't just take and put a serialized Java object into Kafka. You have to use something called Avro, or you can use a protobuf, or you can use JSON. But it'll have to use one of these three types. It'll depend on what makes the most sense for you. If you're using Hadoop, that's where Avro came from. But if you are using protobuf already prolifically in your organization, protobuf may make more sense. Or if you don't know, you could just use JSON. That's perfectly okay too. And then also you can it is provided under a source available license on GitHub, meaning that it is available for you to look at the source and you can use the source. However, Confluent decided to not make it publish it under an open source license like they did for Kafka, because they didn't want cloud providers to be able to take and use it. However, what we did at the last client that I was at, which is perfectly okay, is you can take and put the schema registry in a Kubernetes pod and deploy it to your Kubernetes cluster, and then it will you can point all of your Kafka producers and consumers to that particular instance of the Confluent Schema Registry, and then they can use that Confluent Schema Registry for the schema registry for your application, for your Kafka deployment. One thing you'll want to make sure, though, one thing that I actually solved, one problem I actually solved, was that you want to make sure that if you do deploy it to your Kubernetes cluster, that you specify a high priority value on that particular deployment for your Kubernetes, for your Confluent Schema Registry. Otherwise, it could get reaped by your Kafka deployment, by your Kafka, by your Kubernetes cluster, and then you run into all sorts of headaches, basically saying that where your consumers complain, and your producers complain that they can't find the Confluent Schema Registry. So, any questions around? Any questions about the Confluent Schema Registry? So are Jared? Yeah, thank you for asking. Are the default values specific to the data format? No, they're not. You can use nested types as well. So you can use primitive types. You can use nested types. There are what do they call it? Logical types as well. Is it? I'm drawing a blank as to which ones were logical types. Say a number type was a logical type. There are a few others as well. There's some pretty interesting data types that you can't change. Enum is one that you cannot change. You can't add to that particular data type once you specified it. So be very, very careful about enum types. So, all right, any more questions about Confluent Schema Registry? All right. So Kafka Connect. So Kafka Connect is available under the Apache licenses package as part of Kafka, and it connects Kafka to external data sources. So it enables data import and export. So if you wanted to take and export data from a database table, or from Snowflake, or from Hadoop, or something else, there are quite a number of connectors. And using connectors only requires configuration. So you can do it through a configuration file, or you can do it even through KSQL if you want to. But it does not require any hands-on development to take place unless you want to write a custom connector or modify an existing open source connector. Creating a connector can be pretty straightforward. I think there are two methods on an interface that you need to implement, if I recall correctly, and that's it. And there are two different types of connectors. There's source connectors, which read from data sources, and there are sync connectors, which write to data data repositories. So like a database, again, or Snowflake, or Hadoop, or Blob Store, believe it or not. There are many both commercial and open source software connectors. You can if you just do a quick Google search of Kafka Connect connectors, you'll find, say, the Confluent connector hub page, and there's also quite a few on GitHub as well that aren't listed there. So if you need to look around, you can certainly find them. It also manages details, so you don't have to. In particular, the offsets. So it'll keep track of what the progress is of reading all of the records. So say, for example, you have a JDBC connector or a change data capture connector that you've deployed that you want to use to bring in data, or so it will keep track of all of of what's been read and what hasn't been read yet. So you don't have to manage that yourself. You don't have to manage, say, a watermark or something like that. And also, if a worker dies, if a task on a worker dies, it can take and spin up another task for you. So, for example, if you are constrained by say, for example, the JDBC connector, the number of tasks is limited to each task is mapped to a table. So you can't have more tasks than you have tables, or tables than you have tasks. You can have fewer tasks than you have tables, but you can't have any more. And I mentioned change data capture. So it is a little bit different from the JDBC connector as far as reading from a database, because the JDBC connector can really only capture adds and updates, but it can't capture deletes. So if you want to, if deletes are important to you, you want to look into the change data capture mechanism. There's one called Debezium that is both commercially supported by several vendors, I think. But it's also open source, and it's not supported out of the box by Oracle, but it is supported by Postgres, MySQL, and SQL Server, Microsoft SQL Server. It's actually treated as a replica, so it's treated as a backup of the database. That's how it installs itself. That's how it's installed, and it's pretty clever way to go about things. It treats the database. It reads the database change log effectively. So if deletes are critical to your operation, then definitely look into to a change data capture solution, not only JDBC connector. So any questions about Kafka Connect? All right. So that brings me to Kafka Mirror Maker. So so actually, Jared, you mentioned Golden Gate. So actually, I think Golden Gate will integrate with Kafka Connect to make to allow for Oracle's change data capture solution to happen. I think. Don't quote me on that, but I'm pretty sure that that's the case. So Mirror Maker uses Kafka Connect. It is the cluster replication mechanism that shipped with Apache Kafka. Again, it uses Kafka Connect. It's useful in many scenarios, such as if you have a central cluster and you want to have regional clusters as well that also feed into that central cluster, but may not always be available to connect. And then also for high availability or disaster recovery. So if you have a disaster recovery data center and you need to have that available in case some kind of disaster strikes in your primary data center, this is absolutely an option. For regulatory compliance, so if countries say that, hey, look, the data for my citizens must live in my country, then you can use it for regulatory compliance purposes to make sure that the data is properly replicated without having to take in and manage that all yourself. You can also use it for cloud migration. So if you wanted to move from one cloud to another or from on-prem to a cloud solution, you could set up Mirror Maker to make that pretty straightforward for you. And then also another common use case you could use is if you wanted to have a production cluster where all of your data computation happens, all of your data processing for your data in motion happens, and you want to have a separate cluster for data analysis. You could absolutely do that. So if you want to have data scientists only run queries or deploy inspection applications to inspect the data, you can do it there. And then commercial alternatives also exist. One is from Confluent. I imagine there are a few others as well, but that's the one that comes to mind. These use cases were all drawn from the book Kafka, the Definitive Guide, 2nd edition. I'll have a link at the end of this presentation on how you can get your own copy for free from Confluent. It's quite nice, as well as several other books. Any questions about Mirror Maker? All right. And there's the Confluent REST proxy. It provides a RESTful interface to a Kafka cluster It is very useful for front-end application data fetching and reporting. So if you have a reporting engine and you want to pull from Kafka topic data from Kafka topics, you can do that. Or if you have external application data ingestion and you don't want to go and write a Kafka Connect sync implementation, you can use the RESTful interface to capture a particular topic data, for example. And they're on version 2 now. I want to say that I've seen some early version 3 beta, but I'm not sure how far along it is or what the release date is. But it is quite an extensive API, and it maps by and large to the Kafka API as well, for the consumer API. It only offers a request response model, however, so you can't, so you have to query for the data every so often. You have to pull for it. However, I could certainly see that it could evolve into a reactive model, possibly, maybe someday, we'll see. But I don't see why you couldn't. Oh, what did I do there? You could certainly take and write a Kafka Connect sync that would take and provide lost my train of thought, a reactive REST endpoint if you wanted to try that out yourself. Certainly an idea that came across my mind. You can also, so this is again also provided a source available license rather than an Apache license. So again, if you're running your own cluster, you would need to take and deploy this independently. Any questions about the Confluent REST proxy?
So when you talk about Kafka cluster, you're talking about broker?
Yeah, the brokers. Yes, that's right. Yeah. So typically you'll deploy multiple machines to that all work together in unison as a cluster. Typically 3, or at least at the bare minimum. But I want to say for our development and for our production clusters, we had 25 brokers. But we're also processing a lot of data. So it's quite a bit. All right. Any other questions? I see you're typing there, Mark. I'd be glad to wait until you're done.
No, I'm not typing anything.
Sure. Okay. All right. No worries. Okay. So, all right. Anybody else have any questions about the Confluent REST proxy? So one quick note: you do specify the topic and the offset that you want to read from in the REST call, if I recall correctly. I haven't worked with it myself, but I've seen some examples. But again, these are the details that I know about Confluent REST proxy. All right, so Kafka Streams. So Kafka Streams allows for developers to create stateful, scalable, elastic, and fault-tolerant stream processing applications that are used together. So you can perform some pretty neat things with it. You can just like you would with Java streams, you can also perform a lot of the same operations on a Kafka stream of data. So so think of a stream as a topic, but you can also take and treat multiple events. You can look at multiple events all at the same time, basically. So and you can also have Kafka streams apps that all work together. You have some of the operations that I mentioned were filter, map, and aggregate, and join. You can join streaming data across topics, and and within windows. So a window is like this time bucket, basically. So so if you want to query, if you want to filter all the events that have happened within the past 5 minutes, again, or 5 days or 5 years, you can look at all those events. There are different kinds of windows as well. There's one called tumbling, which is like, say, from 8:15 to 8:20. So we're 3 minutes into that, so you'd only see the past 3 minutes. Once we hit 8:19 and 59 seconds, you'd see all the data that's in the past 4 minutes and 59 seconds. Then once it hits that 5 minute mark, it'll start the next window. So that's a tumbling window. And you have what is called a hopping window. So right now we would be, you can have these hopping windows kind of overlap. There's some great visuals. I didn't want to borrow them though because I didn't have permission. But they're really great. Again, developer.confluent.io has a lot of great videos that talk about the windowing. So with hopping, you can have, instead of having just one window, you can have multiple windows all within a particular time span. So the past 5 minutes. So we'd have, in this case, if we're going from 8:15 to 8:20, we'd have four distinct windows. So 8:19 would go from 8:14 to 8:19. 8:15 would the window would go from, would be another one that started from, say, from 8:10 to 8:15, 8:11 to 8:16, 8:13 to 8:17. Basically, you get the idea. And all those could be queried at the same time, and it would be treated independently as independent windows. And so you have state, though, as you can imagine. So filtering and mapping are stateless operations, but you also have aggregations and joins, and windowing are all stateful. They require state to be maintained. Jumping down here to the bottom, so Kafka uses a lightweight persistent database called RocksDB to manage that state. That database can be persisted to disk. So if a Kafka consumer dies, Kafka Streams consumer dies, or an application dies, then whenever a new one spins up, it can query the state of the current state of the Streams app, and then pick back up where it left off. So in effect, what's happening is that particular Kafka consumer application does not have to read that topic from the very beginning to rebuild the state, basically. So one other great thing that was illustrated was that was mentioned. Mark Fay was he was one of the guys who gave some training. He said, think of Kafka Streams as processing a stream to stream instead of producer to consumer. So you take and you filter, or you map some data, or you aggregate it, you join it, and then you process it, and then you pass it on to another stream that then does some further processing, and then eventually you'll use a Kafka sync connector to take and write that out to an external source in its final form. The data can also be represented as a flow of events, such as a K stream, which can be data that comes together from multiple topics, or it can be represented as the current state of the world through a K table, which has only the latest values of that particular stream that you're interested in. So you can also so ideally, as you can imagine, is you can probably guess, a compressed topic is an ideal backing store, an ideal topic to store a K table, because there's a lot of alignment. So you can also join. You can also have some really interesting joins that happens. You can join tables, as you can imagine. You can join a K table and a K table, but you can also join a K table to a K stream. So if you have these streaming events that are happening and you want to enrich them, so if you, like, for example, if you have customer data that is coming in, and you want to enrich it with customer activity rather, and you want to enrich that with the custom data from a customer profile stored in a K table, you could do that. And then you also, interestingly enough, also join two streams, but you must specify a window for that to take that these two streams are joined within. And a couple of other join types that are available, window types rather, that are available besides tumbling and hopping. There's also one called sliding. So it's like just this constant 5-minute window that is moving along across your across time. And then a fourth one is called session, which will take and wrap around and identify periods of customer activity, and will window those accordingly, and it will manage that for you. So any questions about Kafka streams? Okay, all right. It's pretty cool. And it's definitely a bit more advanced, but it'll lead into our next. Actually, let me show you some sample Kafka streams code. So this is sort of a hello world app for Kafka streams. It is okay. So you'll find it as a pretty common testing or simple, again, hello world. Sorry, got distracted there. So here you have all these streams that these configured properties that you're configuring, and you have here, instead of having a serializer and instead of declaring a serializer or a deserializer, you're having what's called a STRD, which performs both serialization and deserialization. Because you are reading from and then writing back out, reading from a topic or from a stream and then writing back out to another stream. And so we're taking and building a stream here via a stream builder, as you can see right here. And then we're taking and reading it all into text lines. We're declaring a text line stream. In this text line stream, we're taking then performing some familiar operations with the Kafka DSL. There's also what's called a processor API that's available, but by and large, people use the stream's DSL. So you can flat map so here we're flat mapping the values. We're getting all of the words from the list, and then all the words as a list from the line of text. And then we are grouping by the word, and then we are getting a count of the word as well. Then we are taking and writing the word counts to this word with counts topic, and then we are taking and starting the stream. And we're passing the builder along with config to a Kafka stream. And we're starting the stream, and then we're adding a shutdown hook here, and then so what this will do, will count the number of words that are passed in as time goes on. Again, I don't have a sample app ready to show you, but it is pretty straightforward. It'll probably be one of the first streams, Kafka streams apps that you write. One other interesting thing worth mentioning as well is that there is the Kafka streams, and I think it applies to Kafka in general. It has what's called exactly once semantics. So it can be guaranteed that if you enable exactly once semantics, it'll be guaranteed that each message is written to a Kafka topic only once. And so that's really powerful. It's really helpful within Kafka streams, because you don't necessarily want to accidentally reprocess your messages. The other two types that are available are at least once and at most once. And so it just depends on your use case, your configuration, what kind of tolerance you have for data loss or for data duplication. But you can guarantee that data will not be duplicated with exactly once semantics. Now, you can also only guarantee exactly once semantics within the bounds of a Kafka to Kafka application. So Kafka to Kafka stream to Kafka streamer, Kafka producer to consumer. But in order to, if you're taking you have an application that writes to Kafka that's outside of Kafka, you could end up with duplicate messages, and you can't. So the best way to do that is to use, again, a Kafka connector to make that the exact once semantics possible, because writing from a Kafka Connect producer will guarantee exactly once semantics if that is something that you need. And again, same thing with the consumer. You can guarantee that it will be written exactly once. Whereas if you have just a stream that's writing out a Kafka Streams app or Kafka Producer, you can't necessarily guarantee that that it will be written to your external source system only once. So, any questions about Kafka Streams or about exactly once semantics? Okay. Wow. All right. All right. So, testing Kafka Streams code, there is a tool called a library called the Topology Test Driver. I don't have any source code handy to walk through, but you can use test containers. You can also use test containers as a Kafka container, and again, also you use a wait utility to assert asynchronously. But the Topology Test Driver is just a simple you can use it with JUnit, or with, I'm sure, with testng if you're a fan of testng. You don't have to start up a Kafka cluster. However, some situations can be missed, which is worth mentioning. And then what else? So any questions about the Kafka testing Kafka Streams code? All right. So here is an example of filtering events to separate stream in real time. Say you have a stream of blue events and red events. And so you have all these three partitions here that comprise the particular topic that you're interested in. And as you can see, there are both red and blue events that have happened. So we have red, blue, blue, red, blue, blue, red, blue, blue, red. And so you only want the blue one. So you can take and use a stream processing application to filter out all the red events and have only blue events in this particular stream. So you'll bring in the stream. You'll have that stream as part of your streams, Kafka Streams app, and you'll filter out the red and have only the blue streams, the blue events, and then you'll write those to only you'll write those to the blue event stream. And then it's also worth mentioning that there are three partitions in this blue and red events stream. There are three partitions in this blue events only stream. So to write from one partition to another, to write from one stream to another, the topics, both topics must have the same number of partitions. You can perform repartition operations. However, it will require the creation of a new topic, if I recall correctly. in order to allow for that to happen. So it's a bit of a headache. It requires some design up front, but it is certainly well worth the time. And now, if you do repartition, it is okay if you do change the number of partitions. You can add new partitions, but do be aware that join functionality will be broken whenever you increase the number of partitions, because the joins happen based off of keys, and those keys need to match across partitions, basically. So it's definitely something to be aware of. So again, any questions about this example right here, or about Kafka streams? All right. So next we come to KSQL, or as you can guess, it's Kafka SQL. But again, it's KSQL for short. It's built on top of Kafka streams, and you can query K-streams and tables using a SQL-ish queries. If you look at it, you'd almost think it was SQL, really. It uses a lot of same keywords, and it allows you again to perform what's called pull queries, which is just like traditional SQL queries that most of us have already worked with. You can also create applications that generate data, which is referred to as a push query. So really nice. So if you don't know Java or another, but you want to write a Kafka Streams application, you can absolutely do that through KSQL. There's also quite a large library of functions, both functions and aggregate functions. And you can also create custom functions. I think there's only one method that you need to implement in your interface, and that's it. The only downside is that these custom functions cannot be deployed to Confluent Cloud. So if you want to run on cloud, you can't create your own functions. Maybe someday they'll allow it, but for now they don't. And then you can also configure properties and connectors within your Kafka application. And so again, you just use SQL, SQL-ish command. You don't necessarily have to take and use command file, property files to specify your data source. Like there was a great workshop where the entire workshop was done entirely was done in KSQL. So a database was spun up, and then the instructor had folks take and create a Kafka JDBC connector in KSQL, and then create a KSQL application that would do some filtering on the data, and would then take and insert the data, and then add the data to an Elastic cluster. Pretty slick, pretty neat, and again, all without writing anything except KSQL. So again, you had an Elastic cluster, you had a database cluster, added the connector for both the JDBC source and the Elastic sync, and then voila, you have data that's in your Elastic in your database in an Elastic cluster. However, KSQL only works with data already in a topic, so it has to come from outside of the from outside. You could, but that's why you have connectors, basically. So that you can bring data through a connector and then work with it at that point. You can also, again, use the same exact functions that you would in a Kafka Streams application, like I just talked about, mapping, aggregation, reducing, joining, windowing, but many more, again, that are also available in the large library of functions that are available. They're well documented. They've done a great job. It's also provided under a source available license. So if you wanted to run it you could on your own Kubernetes cluster, but again, the Confluence aim there was to prevent large cloud vendors from deploying KSQL without a license. But you can certainly look at the KSQL code. You can contribute even if you want to. So yeah, that's any questions about KSQL at this point? So how does KSQL handle schema evolution? So if a field existed and now doesn't, or vice versa. Again, that's what the Confluent Schema Registry is for. And you add and you remove default data. And but at some point, what will need to happen though is you'll need to take and update that particular application. You'll need to take and rewrite the SQL-ish push query that manages it. And I'll mention that here. I'll show you in just a moment. Great question, Jared. Thank you. So, all right. So here you see pretty much you can think of this as the same thing. See if I can. Oh no, there's a neat. Oh man, it's not showing. Let me see here if I can somehow share my screen rather than this presentation. It's an animation. Let me stop sharing real quick and then show my screen. Stop sharing. Come on. Here we go. Okay, yeah. All right, so let me show this and put it in presenter mode. You can have a better idea of what it does. So there you go. So you can see the balls moving in and out and around, and as the events are read in each of the partitions, you can see that they're being filtered out, it's pretty impressive there. So as you can see here, it's filtering again only the blue balls, only the high readings that are greater than 41, and again it's quite nice. Let me go ahead and close that and then stop sharing, and then I'll share back my presentation. It doesn't go back to the beginning, but it very well may. I can jump to where I was. Yes, it did. Okay. You can bear with me. And there it is. All right. Okay. So there we go. So can you all see that? Is that coming through okay? Or is it kind of pixelated?
Looks fine.
Okay, great. So you have a single solution here with lightweight SQL syntax to build complete real-time applications and streaming ETL setups. So as you can see here, create stream payments. So let me see if I can. Oh, this looks terrible to me. So you have a varchar, the payment amount, which is an int, and a user, which is a varchar and a payment amount, which is an int. With Kafka topic, all payments, and the key is a user, and the value is a format. The value format is Avro, and you input and you emit changes. That emit changes word. You have to have emit changes now as of a relatively recent version of KSQL. So if you use an older version of KSQL, or if you come across an older tutorial that involves KSQL, and it just says create stream but doesn't, but it's complaining at you, make sure you include the words emit changes. So you have a as you can see, you can enrich data in motion, and so as here, this is a kit. You can keep track of payments by particular people. So, for example, if you wanted to treat this as the most recent payment, you could look at this is a K table, and then Jay would have was that 70 or 10? I still can't make that. That's horrible. Let me. And so you have Sue with 15 and Fred is 5. And then so you can also have aggregations that sort of push and pull queries to applications. And so this is an aggregate over across time, for example. So you can have a running tally again also in a K table if you wanted to, where you could say this user payment in this particular case was the most recent one if you want to think of it as a K stream. And then you have so testing KSQL apps. So if KSQL Data Gen is a great way to take and generate test data, you can configure the test data in a fairly straightforward fashion, and you declare what your inputs are. So if you wanted to do some kind of load testing, and but you also wanted to take in put some constraints around what your data look like, the shape of your data, you can use that to generate test data and make sure that you are getting what you expect. And you can also use something called KSQL Test Runner, where you have your KSQL application that you created, and you specify the inputs and the outputs, and you can verify that the outputs are what you expect them to be. And then there's also something that I came across called KSQL DB JUnit tests. And I don't know how broadly it's used, but I thought it's pretty handy. Basically, it allows you to take in, it actually calls the test runner API, and you specify the inputs and the outputs. And so it could make it a lot easier for you to run as part of your CI/CD pipeline. So are there any questions about KSQL DB? All right, pretty neat stuff. Again, it makes it a lot easier for folks who aren't very familiar with developing software development, but are familiar with as far as like they don't know how to program, but they know SQL. You can certainly write Kafka applications and query the data within Kafka topics pretty easily. So here are all of the different systems that connect to that you can connect to right from within KSQL DB using Kafka Connect. Again, quite a number, and this is probably only scratching the surface. So if you see it here, you can talk to it. So books that I think you might be interested in. These are all available from Confluent. You want to look for them. They're all, in particular, Kafka, the Definitive Guide to the 2nd edition, is pretty in depth. About Kafka. It covers, I've covered a lot of what's in it, but at a higher level. And then also mastering Kafka streams in KSQL DB. I have not read yet this one. I have not yet read this one, but it's definitely on my short list. Then I heart logs and make system stream processing and designing event systems, and Apache transaction data streaming, Apache Kafka transaction data streaming are all quite a bit shorter. So if you're short on time but you want to learn about Kafka, you can look at these. iHeart Logs is definitely probably the highest level overview, but it certainly gives a good explanation of Kafka and what it can do. If you're interested in event-driven systems, definitely check out designing event-driven systems. And I've put the QR code here to the URL for the resources. Again, that's Kafka book resources. I don't have the that URL handy. Let me see if I can grab it real quick. There we go. IO resources. Got this in the chat. There we go. Confluent.io/resources. If you don't have your phone handy, confluent.io/resources is this URL. And so again, the resources that are available, we have kafkaapache.org, developer Confluent.io. There it is. Confluent.io resources is where the books are, along with many other things. And then developer.confluent.io, learn testing Kafka is a great resource for learning how to test Kafka. Developer.io, I can't speak enough about it. It's a great resource for learning a lot of different Kafka, all things Kafka. And they also, besides only the Kafka Producer Consumer API and Streaming API and KSQL, they also cover how to use Kafka with Spring, if you use Spring. I imagine we'll add more as well as time goes on, but right now they also include Spring, which is quite nice. One thing that you'll find with the frameworks is that they enable an event-driven model to be programmed to a lot easier. So you can take and you can write your Kafka application, Kafka consumers as event listeners, basically, to topics. So any questions about any of these resources? All right. So again, here's the Confluent Cloud URL if you missed it earlier. But also again with developer.confluent.io, they have a lot of tutorials, and they also include Docker Compose files, so you can run those locally. And then again, thank you to our sponsors. If you didn't catch this earlier, this is the QR code and the URL. If you want to type that in by hand, let me take and grab that again. I'll sort of drop it in the chat so you can click on it. Just a second. And there it is in the chat if you want to click on it. Also, my contact information if you need it. Let me grab the URL to the other Confluent other presentation that was given. Just a moment. And so this is given by Dave Klein. So there we go. That's it. So so it'll go into much more detail about Kafka with producing consumers and how they'll work. A lot of great animation, a lot of great graphics. Much better than my nothing that I didn't add here. But it doesn't cover the components, a lot of the components that I talked about. So yeah, thank you very much. Any questions? Any final questions? All right, so I'll go ahead and stop recording, and we can hang out. Thank you, everybody from YouTube, and stay safe, stay healthy.